multi-threading in Java. Now, over here, a lot of times students struggle with this particular topic just because they don't understand the execution of the program and also need to have some little basics of operating systems to be able to understand this particular topic. A lot of times when students study multi-threading on their own, or maybe when they go through some literature on the internet or maybe some books, they generally get confused. They just don't figure out that what exactly is happening. Like today, the programs that we'll be writing, if you run that program now, it'll give you a different output. You run that program again, it'll give you a different output. So every time that program runs, it generates maybe a different output. Now, this is where the students tend to get confused that, okay, what exactly is happening out here? Because they don't realize that how can a program behave differently whenever I run it at different times. So for understanding this, like what I just mentioned, you need some background from operating system. So what I'm going to do is, for the time being, I'm not going to talk about multi-threading. No. So what I'll be doing is, I'll be discussing these 4 words. These 4 concepts are actually from operating system. So in the simplest possible words, I'm not going to get into the technical aspects of them. We don't need to. We'll just understand these 4 words. The moment these 4 words are understood, suddenly you will find that the programs are very simple. The programs will start making some sense. You'll get different outputs for the same program. You will be able to understand very easily why is that happening. So these are the 4 words that we will be talking about: thread, time sharing, time slice, and preemption. So what exactly is a thread? So let's keep things very simple. See, understand this. On my computer, everything that happens or everything that is done by 2 people. One, the final work is done by the most important worker on my computer, which is the processor. And the second is obviously the big boss on your computer, the operating system. We all know that operating system is someone who will control everything that happens on your system. So that is what is the role of an operating system. Now suppose if I wanted to type something on my computer. So what I do is I start with an application, say MS Word. So I've just started with MS Word. See, all these softwares that we install on our computers, they are like tenants living in a city which is owned by the big boss, the operating system. So they are all tenants. Now for MS Word to process whatever is needed, they need to reach this particular processor. They need the services of this processor. But understand, no application software is ever allowed to interact directly with the hardware. It's not possible for 2 reasons. One, if everybody is allowed to interact directly with the processor, then it will not be possible for the processor to interact, because there's just one processor and there can be hundreds of applications running simultaneously. And also the formats that my processor understands, my application softwares like MS Word, they don't generate that format. So even if this communication was possible, it's not going to materialize into anything fruitful. So this is not happening. So suppose if I've just, I wanted to type something, I've just started MS Word. What MS Word will do is it needs services from this particular processor. So what it will do is it will send a request to the big boss. The big boss will appoint a small processing unit from its side, which is called as a thread. So suppose thread 1. Now what this thread 1 will do is this thread 1 will act as an interface. So you can say that this is now the link between the application and the processor. So when you say I'm typing, say in MS Word, and if it is happening, that what this means is that there is a thread for MS Word which is created and which is under execution as of now. A thread is the smallest processing unit on your computer. So at the lowest level in your computer, if there is one unit which gets executed, then it is what is called as a thread. Okay, so suppose I'm now typing in MS Word, I've been typing something. Suppose say I've been typing my notes that I was preparing. Now simultaneously what I thought is, okay, as I keep typing, let me also listen to some music. Now again, if I want to listen to some music on my computer, so suppose I've started another audio player, right? Suppose say a music player I've started. Suppose I've started with this one, say called Winamp. Now Winamp also, for playing music, it needs the services of this processor. Again, Winamp is an application software. It cannot interact with the hardware directly. So what the system would do is, the system would appoint another thread in your system as of now. That is what they'll do. So now what is happening is I'm typing at the same time, I'm also listening to the music. So over here, there are multiple threads which are running parallel. Suppose while writing these notes, I wanted to create some diagrams, I wanted to edit them. So I've started with another software, say MS Paintbrush. Now when I start with Paintbrush, what the system would do is the system would appoint another thread. So for every application that I create, the system will create a thread in my system, and this thread will keep executing to get my job done. So a thread is defined as the smallest processing unit on your computer. For every application that you start, the system will run a thread, will create a thread for you. This thread will get executed on your computer, and then the processing will take place. So that is why I could keep typing, and at the same time, I'm also listening to the music. At the same time, if needed, I also keep editing some diagrams or whatever I wanted in Paintbrush. Now over here, if you see this figure, over here, I have multiple applications running parallel. This is called as multi-processing. My system is capable of executing multiple applications simultaneously, and for this to happen, we need the concept of multi-threading. So what you see on your screen are multiple threads which are executing simultaneously. Now this is what is multi-threading. It is because of the concept of multi-threading that we have multiple applications running parallel on our system. So this is what happens over here. I hope this is understood. So this is how we have multiple threads running parallel. But now there are certain issues that we need to be talking about. See, this is okay for supporting multiple applications. We've created multiple threads in softwares, right? So multi-threading is being implemented. But then my problem over here is, or the argument that I can put up over here is, you have created multiple threads. That is okay, right? So that is fine. In software, that is very much possible. But I have just one processor on my computer. So even if there are multiple threads running parallel, there is just one processor to support it. Now understand the issue. Suppose, say there are four of you, and say I'm speaking to you guys. Now, if all four of you ask me something at once, now I am just one person. How will I able to provide you with answers simultaneously? So exactly the same thing is happening over here. There are multiple threads running over here, and for giving support to this particular thread, we have just one processor. Then how is it possible? Or when there is no support in the hardware, how does this work? See, one possibility is we might be thinking, okay, there might be multiple processors on our computer. If this was the case, we would have agreed that, okay, yes, there are multiple processors and each processor is answering to a thread. But obviously this is stupid. This is not possible. All the computers that we are working on, they all have a single processor. You cannot have multiple processors like this. No. So the argument now is that I have multiple threads and I have a single processor. Then how is it that all these applications actually work simultaneously? Now please understand this. For making this happen, or for ensuring that multiple threads run parallel on the computer, the developers, they came up with the idea of time sharing. Now, what do you mean by time sharing? No, it is not possible for your processor to actually support all these applications at one go. This is not possible. See, when you're executing these applications, they are actually in a queue. So what happens is your processor will for say initial, for some time it'll process MS Word, then it'll process for say Winamp, then it'll process for Paintbrush, and then go back. So this cycle goes on. It keeps typing for some time, it keeps singing for some time, it keeps painting for some time, and this will go on. So this is how your processor actually supports all these applications one after other. Ideally, I should have drawn it like this. So time sharing is where every application is given services of this processor for some time. So actually there's a queue. You always have a processing queue like this. So what MS Word will do is, the MS Word will get access to this processor for some time. MS Word will do its work, and whether it completes or not, it'll just leave the processor and go back and join at the end of the queue. If you see MS Word has gone at the end, then Winamp will come. Winamp will start singing. It'll get access to this processor for some time. It'll play that song for some time and then go back in the queue. Then Paintbrush comes in. Paintbrush does its work for some time and then go back, and then MS Word comes in. So these applications, they'll keep coming in a cycle like this. And this is how, on time sharing basis, these applications will work. So every application gets services for this processor, say for a specific interval. Something like this happens. Now the question that I need to answer is that if these threads are getting services one after the other, then why don't we realize it? See, it literally happens like this, that MS Word gets services for some time, it goes back. Winamp gets services for some time, it goes back. Paintbrush gets services for some time, it goes back, and then comes MS Word. Over here, each processor is, each application is being processed for some time, and the processor keeps switching between these applications. And this happens so fast that we don't realize as the end user that this is what is actually happening. So we never face this scenario that, okay, I type a line, then I listen to one line of the song, maybe I draw something once in Paintbrush. No, we don't realize it, but that is actually what is happening over here. So multi-threading is possible because of this concept of time sharing. I hope this is understood. Okay, but now what happens over here is, now understand, suppose assuming that, say, MS Word is doing some work, Winamp has to wait till MS Word completes whatever it is doing. Say Paintbrush has to wait till others are doing something. Suppose that the time required for Winamp to complete its work is, say, 0.1 seconds. Now I'm taking very big numbers. For computers, this is very big. Suppose the time required for Paintbrush to complete its task is, say, 0.1 seconds. Suppose MS Word is doing say more of work, and say it needs, say, 0.6 seconds to get its job done. Now understand, for Winamp to get its job, which needs 0.1 seconds, it has to wait for 0.6 seconds. So the total amount of waiting time or the processing time which you'll get is 0.7 seconds. Now practically this doesn't make sense that you make an application wait for so long that the amount of work to be done is lesser than the amount of the waiting time. So the overall efficiency would be lost. So time sharing is a good concept, but time sharing can be unfair to applications which do not need a lot of time to process something. So how do we ensure that the efficiency is retained and no application is required to wait unnecessarily? So to make the concept of time sharing fair, we introduce the concept of time slices. Now, what do you mean by time slices? Understand this. What do you mean by time slices? So for every computer, for every processor, or for every system, there is a time slice defined, predefined time slice. So what happens is, understand, suppose the time slice I'm assuming is, say, 1 second. Now it's much smaller than 1 second, this is actually nanoseconds, but for simplicity I'm taking 1 second. If the time slice for this particular system is 1 second, what this means is any thread which gets the processor will get the processor only for 1 second. So what happens is, MS Word gets the processor for 1 second, then MS Word will do whatever it can for 1 second. As soon as that 1 second is over, it will leave this particular processor and go back. Winamp comes in. Winamp also gets this particular processor for 1 second. It does its work in 1 second, leaves it, goes back. Paintbrush does its work for 1 second. After 1 second, leave the resources, go back, and so on. So this will go on and on and on. So no thread is ever going to get the processor for more than 1 second. See, you can come inside this particular queue any number of times. You can keep coming again and again and again. So what happens is, the applications which need, say, more of processing time, they'll keep coming into this queue over and over again. But the smaller applications will just come, finish this task, and leave. That is why the processing remains fair for all the applications. So that is why time sharing is used with time slice, and that is how the applications will work simultaneously. But suppose, understand this. So we've understood thread, we've understood multi-threading, we've understood time sharing, we've understood time slice. So time slice is making multi-threading fair to all the applications. But now the question that needs to be asked is, see, this is all good. Everything is working fine. Every process comes, it catches hold of the thread, it does its work for some time. As soon as the time slice expires, it leaves the thread, goes back, and this goes on, right? This goes on like this. But suppose if we have a mischievous thread, the threads which don't abide by the rule, they are called as mischievous thread. Now suppose MS Word is a mischievous thread. Suppose MS Word has got access to this processor, say, for 1 second. So the time slice is 1 second. Suppose 1 second gets over, but MS Word still refuses to leave this process. So I have a thread over here which has started playing mischief. Now if this thread starts misbehaving, all other threads will just keep waiting and waiting. So my entire system will get destabilized. If I have even one thread which starts playing mischief, in that case, it can bring the entire system to a halt. The question is, how do we tackle something like this? So the solution to this particular problem is, see over here, what we are forgetting is that this entire thing is being looked at or is happening under the control of the big boss, your operating system. When all this is happening, your operating system will always keep an eye on what's happening. The moment this operating system sees that there's someone who's playing some kind of a mischief, this operating system has some bouncers, the Gunda types, with him. So what this operating system will do is, now suppose this MS Word is playing mischief, it is not following to the rules. What this fellow would do is, this fellow would send someone from these guys. They will come, they will snatch away the processor, they'll snatch away the resources forcefully from this particular thread and take this thread outside this particular queue. This process of taking away the resources forcefully is what is called as preemption. So the reason why our systems don't get stuck up all that easily is because of this idea of preemption. So what is preemption? Preemption is when the system will snatch away the resources forcefully. So all these combinations put together will make sure that multiple applications run simultaneously on our computer. So for running multiple applications, for running an application, we need a thread. For running multiple applications, we need multiple threads. That is multi-threading. For multi-threading, because there's just one processor, for everything to work fine, we need the concept of time sharing. For time sharing to be fair to all the processes, we use the concept of time slice. And to make sure that no process or no thread can actually play mischief and bring the system to a halt, we use the concept of preemption. If these four words are understood, you will be able to understand the programs easily. Now we are all set to get started with the concepts of multi-threading in Java. Now that we've understood this, let's get started with multi-threading. So the first question that we need to understand is a thread lifecycle. All those who are studying this from the examination point of view, if you're preparing for your university exams, thread lifecycle is one of the more important questions that we have in threads. Now, what exactly is a thread lifecycle? Now, to keep things very simple, as soon as I start an application, a thread is created. And now in this case, I'm running this entire presentation using Microsoft PowerPoint, PPTs. So as soon as I start this particular PowerPoint, a thread was created. Once this session gets over, I'll just close this PowerPoint. The thread will then get deleted. The life cycle will basically talk about the states that a thread will go through right from the start, right from the creation to its deletion. So what are the states that this thread will go through? See, again, this is not anything that is required to be remembered or ratified. Just understand this. How to understand this? Now observe this. See, when I actually start my PowerPoint presentation, it doesn't start with the way you have been seeing the screens. I will always get this particular screen. Now just understand, I've started this application. So this is what my PowerPoint screen looks like. And now in the background, the thread has been created. Now just think, what are the operations that I can perform now? One, suppose I realize, okay, array, this is the wrong topic that I've started, right? So what I can do is I can just go and click this particular application. So without doing anything, I can shut this particular thread. Or maybe if I realize, yes, this is proper. Now I want to show you the presentation. My presentation is not going to work like this. I will have to get this presentation running. Right, now it is okay. Now if I click next, previous, it will keep taking me to the next and the previous slides. So I need to get this. So all you need to be able to do is, you need to be able to correlate what is happening with the thread in the background. The PowerPoint presentation that you are seeing obviously is working with the help of a thread. So just listen to the words carefully. You will know what the answer is all about. Now, as soon as an application starts, I'll create a thread which is in a newborn state. Now, when I say that this thread is in a newborn state, what this means is this thread has just started, but it is not capable of doing anything. Now, observe this. Suppose I've started PowerPoint. I get to this particular screen. The thread has been created, but I'm not in a position to run this particular thread. I'll say that this thread is not yet in a runnable state. That means this thread cannot run. I have to get it in a runnable state. Only then this presentation will work. Okay. One more thing that I could have done is, suppose I realize that this is the wrong presentation. I can just close this window from over here, which will delete the thread. So from a newborn state, I can go directly to a dead state. Now there is a function called stop. in Java, there's a class called thread, which will provide you with all the tools that are required for working with threads. So the stop method will execute, it will kill the thread. So if I start an application and just close it then and there, then it goes to a dead state. But suppose I realize that this is proper, then I need to start this particular thread and get in an active state. So when I'm running this PPT, what I do is I first get this particular screen. From over here, I cannot run this presentation. Then I click something and I get it to this state where this presentation is now ready to run. I'll say that this particular thread is now in an active state. So after you've created a thread in your programs also, you will be required to make these threads or get these threads in an active state by using this start function. Now, once in the start function, the thread will be in a runnable state. You can say that this thread is now ready to get executed. This thread is in a runnable state, right? What happens next? It is in a runnable state, and in an active state, it will keep toggling between the runnable and running state. A thread always spends major part of its lifetime in these two states, runnable and running state. Now, I want you to understand this properly. What is the difference between the running and the runnable state? I'll just go back to the slide which we've been using earlier. Now look at this, observe this. See, now I have three applications running. MS Word. See, currently only MS Word is getting executed. So the thread which is currently under execution is MS Word. Now just look at this thread, Paintbrush. Now this thread is ready to get executed, but it has to wait in the queue for its turn. So I can say that this thread is in a runnable state. What this means is this thread is ready to get executed, but this thread is currently required to wait for the allocation of the resources. So this thread is in a runnable state. It's in a waiting state. Then maybe MS Word completes its work. Paintbrush comes a step forward, but it is still in a runnable state. Now Winamp does its work. Now Winamp completes its work. Now Paintbrush comes. Now Paintbrush has actually got the processor. Now actual execution of this Paintbrush starts. I will say that this thread has now gone from a runnable state to a running state. What this means is that this thread is now actually under execution. Now it will keep working till its time slice expires. As soon as the time slice expires, this thread will have to leave the resources and go back at the end of the queue. Can I say that this thread Paintbrush again from running state has come to a runnable state? So it will keep going through this particular queue, and after its turn, it will keep coming back. So over here, all this is doing is it is going from runnable to running state and running to runnable state. So that is exactly what we are trying to mention over here. Now this is what is happening. Your thread will keep toggling between running and a runnable state. Now from any given state, you can actually get into a dead state by executing the stop method. So now that we've understood the execution, let's try and understand one more state which a thread goes to is what is called as the blocked state. Now first understand what is a block state, and then we'll talk about what are these functions. Don't bother too much. Let's just understand what is a block state. Now I'll give you an example. Now suppose if I'm running this PowerPoint presentation, if I just go over here and if I just shut this window from this right corner, this button, then the thread is killed, right? So it goes into a dead state. So that is done. But suppose say I was just playing say a video from YouTube, right? So that video is playing now. Or if you run these applications, say if you are running this presentation also say from say some particular website. What happens is, suppose if I'm playing a video from YouTube, when I pause that particular video, see it does not close the YouTube application. It just stays where it is. Now that is where I'll say that the thread is in a block state. Now suppose understand this. Suppose this is the processor, right? Now there is some application A running. I have a YouTube video playing over here. So Y is my YouTube application, and there is another application called say C, which is running. Now all those applications which are in the queue are considered for processing. Now when I pause, what actually system does is, it will not kill this application. If it kills this thread, YouTube will shut. I don't want that to do. So when I hit that pause button, what the system would do is, the system would remove it from the processing queue and keep it outside this queue. So something that is outside this particular queue is alive, but it is not considered for processing. So what you will find is that that particular video is paused for the time being. It will remain paused till you go to that particular video again, and then you resume it. If you play it again comes into the queue, and then it will start playing like this. So block is, you can say that temporarily your threads are put outside the processing queue. Now there are three different ways of doing it. The first method, there are three different methods that Java provides us. First is suspend. Now suppose there is a thread X which is part of this particular queue, right? Observe. Now again, there is this processor P. There are three threads, thread A, thread B, and thread C. I'm going to block thread B using different methods. Currently A is being processed. Now suppose if I suspend this thread, if I block this thread, in that case this thread will go out. That is for sure. Now that remains constant, because every thread which is blocked will be put outside this queue. It has gone outside this queue, right? But understand, if I have blocked this particular thread using the suspend method, then this thread has been suspended indefinitely. That means it cannot come back and join the queue. It will have to keep waiting till at some stage I go and I issue a resume instruction, and only then that thread will come back. Now suppose if I was playing a YouTube video, if I pause it, that video is paused indefinitely. At some stage I will be required to go and play that video again, only then it will resume. It will never come back and start playing again on its own. So suspend will suspend the thread indefinitely till you come back and issue a resume command. The second one is wait. Now what exactly is wait? See, suppose this thread B has been blocked. Now suppose if I say I blocked this particular thread using this wait method, and I say wait for say 5 milliseconds. What this thread B will do is, this thread B will wait for 5 milliseconds, and after 5 milliseconds it will ask the system, can I come and join the queue? Then suppose the system says no, wait for another 5 milliseconds. Then thread B stays blocked for another 5 milliseconds. After those 5 milliseconds, the thread B again asks the system, can I come in and join the queue? If I say resume, yes, now it will come back and join the queue. The point here is, when you block a thread using this wait method, it will keep seeking permission, and if it is permitted, only then it can come back and join the queue. When the thread was suspended, it had no say, it was just waiting. The third and the most important one that we have as far as our programs are concerned is sleep. Now suppose this thread B over here is blocked, right? Now suppose I blocked this particular thread B, say for 5 milliseconds, and I blocked it using the sleep method. What it will do is, it will wait outside for 5 milliseconds, and at the end of 5 milliseconds, it will come back and join this particular queue. It does not need any permission, or it does not seek any permission. It will just come back and join this queue and then go ahead. See, when we design our application, we have something like a timer. So what I want is, suppose say a screen has appeared, this has to stay for 5 seconds and it has to go away. So what I'll do is, that screen comes in, I block that thread for 5 seconds, it will stay where it is for 5 seconds, and after 5 seconds it automatically disappears. So timer and all that we use, they are nothing but application of sleep methods. Also, going further in our programs, we will be using sleep methods. So you can block a thread using 3 different approaches, depending on what exactly do you want to do. A thread from its block state can also be killed and sent to a dead state directly. Also, there's a method called notify in class thread. If there is any change in the execution schedule of the thread, we use this notify methods. So this diagram actually now gives you the thread life cycle. These concepts, what we just discussed, are very important from the aptitude test point of view, from the interview point of view as well. Thread life cycle. Now we'll get started with the programming part of multi-threading. So over here we'll see how to create a thread, how to make these threads execute, and so on. And more importantly, after you've written the program, you should be able to relate to, you should be able to understand how and why are the outputs getting generated in the manner in which they will get generated. Okay, how do we create a thread, please? See, in Java, we have a class called thread. So whenever I'm required to create a thread, I need to derive a class from this class called thread. So how do we do this? Now what I do here is, please observe this. I'll first create a class. Suppose say T1 extends thread. This class T1 is derived from class thread. Now this T1, you could have used any name that you feel like. It is derived from class thread. So keyword extends is actually, you can say, is the concept of inheritance that we are implementing over here. So class T1 is derived from class thread. Now inside every class that is derived from class thread, we will be required to write this method called run. Now this run method will precisely define the functioning of this particular thread, or this class, this function run will decide what exactly the thread would be doing. In other terms, if you want that the thread should do something specific, then that code for whatever you need to do, everything has to be written inside this run method. So inside this run method, timing, what I've done is I've written a simple for loop for I is equal to 1, I less than 10, I plus plus system.out.print T1. So whenever this run method will execute, it will print this T1 say 10 times. Now, please understand, I've derived this class T1 from class thread. I haven't created the thread as yet. T1 is a class which, if needed, can create a thread for me. I haven't created the thread as of now. Or in other words, later on, when I create the object of class T1, that is what will become a thread. So if somebody is asking me, what are the steps in creating threads in Java? Step 1, you derive a class from class thread. 2, you add run method inside that particular class. And 3, you create an object of this particular class. This object that you create would be a thread. So over here, what I've done is I've created this class T1 from class thread. I've written this run method. I haven't created the object of class T1, so I haven't created a thread as yet. Now, similarly, because I want to display, I want to discuss multi-threading, I want to take up multiple threads, so I've created another class T2. I can create any number of classes like this. Class T2, which is also derived from class thread, so T2 is also a thread class. Now what I do is I write a run method over here. In this run method, what I now do is I write a for loop which will repeat 10 times and which will display T2. So as of now, I have two classes, T1 and T2, both capable of giving me threads. I haven't created a thread as yet. But as in when I create a thread using object of class T1, it will keep printing T1. Whenever I create an object of class T2, which would be a thread, and on its working, it will keep printing T2. So I have just created two classes T1 and T2, which are capable of generating a thread, but we haven't created thread as yet. Now when we go ahead, what happens over here is, now please understand, class data. Inside this, I've written this main function. T1x is equal to new T1. X is an object of class T1, which is derived from class thread. So X is a thread. T2y is equal to new T2. Y is an object of class T2, which is derived from class thread. So Y is a thread. So I've got these two threads. These two threads are in a newborn state. If I want these threads to work, I have to get them in an active state. X.start and Y.start will get the thread in an active state, and these threads will start working. X is an object of class T1, so X will basically execute this run method. Y is an object of class T2, so Y is going to execute this run method. So over here, I've created two classes T1 and T2. These are the two threads X and Y for class T1 and T2, and now they are working. Now that this code is done, what is going to be the output and why? Please understand this. Now I have two threads running parallel. Obviously, they'll be executing on time sharing, time slice basis. So understand this. See, I have say a single processor on my computer. As an example, I've taken this processor. Now over here, I've written X.start and Y.start. So because X.start has been written first, so X will start executing first. So X will be allocated some resources. So X will start executing the run method. What X will do is, X will start this particular loop, which is supposed to display a T1 10 times. But what happens is, suppose X will print T1 for the first time, X will print T2 for the, T1 for the second time. After it has printed, say T1 twice, its time slice will expire. Now, when the time slice expire, the thread is expected to leave the resource and go. So over here, this thread X will then leave the resource, go back. Now Y gets this particular thread. So T2 will get executed a couple of times. Then Y, the time slice will expire. Then Y has to give up the resources, go back to X. This will print T1. Then Y will print T2 and so on. So as this program goes ahead, you will see that you will keep getting some T1, some T2, some T1, some T2s and so on. So over here, you will see that there are two threads which are running parallel. Now observe this, observe this. See, understand the programming that you've done. Suppose the programs that you've written so far, suppose if you had written this first for loop, followed by the second for loop. Obviously, the codes that you were writing would execute in such a manner that this loop will first complete and only then this loop will start. But look what has happened over here. I have two for loops over here, one inside the run method in T1 and the other inside run method in T2. Now, if you see, this for loop and this for loop are both running parallel. So two parts of the same program are running simultaneously because now we have two threads which are executing the different parts of this particular program. So because of this time sharing and time slice, you will get your output as this. Now, in this program, if you type and get this output, what we are expecting is that you'll get some combinations of T1 and T2, something like this. But the fact is, when this program runs, you'll get all T1s together, followed by all T2, something like this. You will get all T1s followed by all T2s. Now that is what is happening. But then, if this is the output, then the whole concept of multi-threading that we've discussed is lost. Now, why is this happening? I told you that I'm expecting some combinations, some T1, some T2, some T1, some T2 is what we are expecting, but that's actually not happening out here. Now, why is this? Now, please understand this. See, over here, when I've created an object of class T1, it is supposed to execute this loop and print T1 10 times. And when I've created object, say Y, of this class T2, it is supposed to execute this loop and print T2, right, 10 times. Now what happens is, because the processor that we are working with are so fast these days, that once X gets the hold of this particular processor, it will get the entire job done in just one iteration, one step. So it will be T1, T1, T1 together. And then once this expires, before this time slice could expire, thread X would have completed its work. Then thread Y will come in. Now thread Y will come into the picture and it will print all T2. So if you're getting all T1s and all T2s, which you will in this case, there's nothing wrong with multi-threading. It's just that the processor that you're working with is so fast that it is now capable of completing the entire task in one go, right? So just to make multi-threading visible to you, what I'm trying to do is, see, this program that we've written, this is running too fast for us. I'm just adding something to this code, which is actually slowing down this program on purpose. The reason why I'm slowing down this program is so that you can actually see the outputs properly. So I'm just slowing down the program now. So my program remains the same. All I'm doing is I'm adding something which will make sure that multi-threading is visible. Observe what I've done. It is exactly the same program. I've created class T1, which is derived from class thread. You have this run method. Now, earlier what was happening is this loop was executing very quickly, right? When I'm printing T1 10 times. But now what I've done is I is equal to 1, I less than 10. I'll print T1. After printing T1, don't bother about try catch at the moment. I'm putting sleep 2000. Now 2000 is 2000 milliseconds. So this is actually, I'm blocking this thread for 2 seconds. Now whenever we use this thread method, this sleep method from threads, it can generate an exception. That is why we've written this try catch block. So this try catch sleep that I've added over here, if you see, this has got nothing to do with the logic of the program. This is just slowing down the program. So now when this loop executes, this prints T1 for the first time. It goes into the sleep mode. It stops for 2 seconds and then come back and continue. So after every T1, my system is stopping for 2 seconds. I'm doing this so that the time slice should expire. Similarly, in this particular class called T2, I've added a sleep of 4000. Now it's up to you whether you want to use 2000, 3000, 4000, whatever. So over here also, you'll print T2, you'll go to a sleep mode. That means you'll stop for 4 seconds and then come back and continue. Now, by doing this, I've slowed down the execution so that the time slice will expire. And now when you run the program, you will see that your output comes slowly, and it would be some T1, some T2, some T1, some T2. We've done this, or we've just demonstrated multi-threading by just slowing down the execution of the program. Just make this change if you're typing, and you will see that the outputs would be fine.